Welcome to another episode of Xman Hack. In this episode, I'm going to explain what a transistor is, where you can use it, and how. Transistors are digital switch, like your light switch, but much smaller and controllable with a small charge. There are millions of them on your CPU right now, and these ones are turning on and off very quickly to do a lot of calculations. There are different types. For example, there are the NPN, the PNP, the MOSFET, and relay. There are also the solid-state relays that we'll talk about it later. You can use them to turn on and off a device with a simple high and low digital pin, or try something that it can be high voltage, like a 12 volts motor or a 220 lights bulb. There are so many ways so you can use this item, and I'm going to show you some example. I'm going to show you how to connect one transistor NPN to an LED, which in theory needs to be connected with an external power supply because it should drain too much power. But in this case, I'm just going to use a 5 volts from the Arduino pin. So, what you have to keep in mind is that a transistor has 3 pins, as you can see here. Each manufacturer has a different order, and to make sure which order are they and where are positioned the pins I'm going to describe later, it's better that you check your datasheet of the model that you bought. So there is the emitter, that is the pin where you connect the source of your power, the base where you connect the digital pin which drives the transistor, and the collector where you connect the device that is going to drain the power. So in this case we're going to connect a ground pin as we're using an NPN type, but using a PNP type we need to connect the positive pin. This is the main difference between these two types of transistors. Now I'm going to just make a simple script that will turn high to the pin 5, wait a second, and then turn low on the pin 5. So now we're going to connect on the breadboard on this LED here. So in my hand I got a NPN type. So by reading the manual, actually the data sheet, you can see the first one pin is a collector, the second is a base, and the third is an emitter. So we're going to put these ones down on the breadboard like this. So the LED here is going to have the ground pin on the collector and the positive a little bit far. We're going to use a resistor between the base and the actually digital output of my Arduino to avoid any discharge and going through my Arduino so it will not damage it. And here we have the Arduino, which already have connected the cable to the pin 5, and we're going to connect the other end to the resistor. Right, here we're going to have our ground, and we connect to the pin ground, and then to the emitter, which is the third one. And last, it's our power. We're going to connect to the 3.3 volts, and then to the positive pin here. As you can see, it's not very bright, but you can see that it's flashing. So this is our script, the flash. It says turn on for a second and shut off for a second. So now that we know how to do this, we can try with the other type, which is the PNP. And the other thing that we're going to change is where it's going to drain the power. So instead of using the ground, we're going to use the positive pin, which is the 3.3 volt. So We can remove the cables here, all of them, just to make sure. So we just start from scratch. And then I've seen that between this version and this version, the pin order already changed. So if I go back to my datasheet and I'm going to check which are the pins, the first one is a base, collector and emitter. So let's put down the breadboard. So we flip LED, so this is the positive pin, and we put the positive pin down to the collector and then a bit far. Use our resistor that I forgot to say, this is like 100 ohms and it can be like a bit higher, just not too much higher, otherwise your transistor might not turn on because you don't give enough current. Right, we connect back the 5 pin, the ground that is now on the outside, the 3.3 volts to the meter, and that's it. That works. So we tried with a NPN type and a PNP type. So as you've seen, it just changed. One uses positive, one uses negative, that is ground, one is the positive pin. This is another example that it can be used. We can use a MOSFET, which is basically, whether it's like basically the same, but it is another labeling for the pins, which is, in our case, the MOSFET is drain, which is our collector, the gate, which is our base, and the source, which is our emitter. So if we remove all the pins again, so we start from scratch, put this one there. So we check the data sheet. So this is the drain, gate, this one in the middle, and the source. So we put it down. So the drain is where it's going to be on my LED. Just to make sure, we're going to use a ground pin. Let's put back the ground pin on the source. We put the gate, the resistor, and then the power, the 3.3 volts. Actually, I put too much voltage on this LED. But as you can see, it's still working. Different transistor can drain less and more current, so as you can see, my LED is kind of burned somehow, because I didn't actually check the datasheet of the LED, and the MOSFET was releasing more current than my tiny transistor PNP, NPN. So one last type of transistor, as we can say, which are able to drive AC power, is a relay. I actually don't have anything to test this one, but what I can say, what I can show you is the actually working relay, which is you're going to hear the sound of a click and an LED to turn on and off. In this side, you should connect the neutral of your device. That can be a light bulb. So in the middle ones, the common, and then on one of the two, which is the datasheet of your device, you can see normal state is going to be connect short, probably the first two, and then when you active the relay, it's going to short the next two. So the connection is very simple. It's actually simpler than the MOSFET, and it's basically the same for each one. So we're going to use some jumpers. So let's see if I can show you the pins here. If it gets focus. Right. So you can see a small label down there. This is a signal. And the middle one is 5 volts and the last one is ground. On the other side we got these ones, which the middle one is the common, and then in each side is very short, like neutral, like no state, and when you send high it shorts this one. So we're having our signal, CO5, the pin 5. The code we don't change, it's all the same. We put on the source, we connect the power, which is a 5 volts. I didn't see anything that went low, like I didn't see any relay that was using less than 5 volts. So I suppose all the relays on the market are using 5 volts. And the ground. As you can see, the relay turns on and off. And you can hear the click. It goes like click and click. This is because inside there is a mechanism that it turns on and off. Basically, it touches together the two wires in somehow. I'm not going deeply inside in this information, but you can look it up, and there is some schematics how it's actually made inside. So that's it for the explanation how a transistor can be used on your project and how you can hook it up. It's very simple. I'm going to share on the links below my datasheet of my 3 transistors. And yeah, one last thing is that you can find one of these in a solid state, which are the benefits are the faster, and then they don't make any sound. So it's everything like it's a chip basically, rather than something mechanic that moves inside up and down. So that's it for this episode. I hope you enjoyed that, and stay tuned for the next one.